Hello students, welcome back. Today I'm going to discuss a very important topics for B.Sc semester 4 students. Let's move on. The topic is called Jahn distortions. So first I told you why this kind of distortion occurs. Suppose your orbitals, degenerate orbitals are asymmetrically occupied, then this kind of distortion arises. Now I will show you with an example. Suppose you have D1 octahedral symmetry. Then D1 electrons occupied the T2G orbitals. So the single electrons can either occupy XY orbitals or YZ orbital or XZ orbitals. So we termed this configuration as asymmetrically distributed or asymmetrically occupied because all the three orbitals are not occupied by electrons. Whereas if you have D3 configuration, then all the three orbitals will be occupied by three electrons. So these are symmetrically occupied. So I think you understand the difference between asymmetrically occupied. These are asymmetrically occupied and these are symmetrically occupied. Suppose you have D2 configuration, then also the D2 configuration will be asymmetrically occupied. Now what happens when they are asymmetrically occupied? Suppose you have D9 octahedral symmetry. So again, D9 octahedral symmetry will be asymmetrically occupied in the EG level because look at the third last electrons. Last electrons may either occupy the Z square orbital or the X square minus Y square orbital. So EG orbitals again asymmetrically occupied but not T2G. T2G are symmetrically occupied. So I have written here some points for you. In electronically degenerate state, if orbitals are asymmetrically occupied, then they get more energy. The system tries to get rid of this extra energy by lowering the overall symmetry of the molecule that is undergoing distortion, which is known as Jahn distortions. That means if your degenerate orbitals will be asymmetrically occupied, then this will be in higher energy level. The system tries to get rid of this energy level and they lowers the symmetry by distortion, by undergoing distortions of the symmetrically occupied and unsymmetrically occupied orbitals, and this distortion is known as Jahn distortions. So what happens? Suppose in case of D9 system, the last electrons occupy the D square orbital, the Z square orbital, then the electrons are more concentrated towards the Z axis and there will be more electronic repulsion, electrostatic repulsions associated with the ligands and the metal along the z-axis. That's why the bond along the z-axis will be more elongated. So remember, if the electron occupied z square orbital, then the bonds along the z-axis will get more electrostatic repulsion and the bonds gets elongated. So there will be different length in the bond length along xy axis and along the z-axis. Conversely, if the electrons, suppose these electrons now occupy x square minus y square, then repulsion in that axis, repulsion in x square in x and y axis will be more and bond length along these two axes will be elongated, or we can say that the bond along the z axis will be shortened, not elongated. So I think you understand what is Jahn distortions. Now I am going to more details. There are salient features about this kind of distortions. Mostly octahedral, this kind of distortions occurred in octahedral environment. Theoretically, D3 is symmetrically occupied. Similarly for D10 and D8 and high spin D5 and low spin D6. All are symmetrically occupied. So you cannot have any kind of distortion for these kind of configurations. Now, for high spin D4, just to remember, if you put the electron in high spin D4, then T2G will occupy with 3 electrons, whereas EG will occupy only 1 electrons. So this will be termed as asymmetrically occupied. Similar for low spin D7 and low spin D9 configuration. So Jahn distortion is usually significant in asymmetrically occupied EG orbitals. So this point is very important because T2G and EG, both orbitals may have asymmetrically occupied electrons. But Jahn distortion will affect more significantly when EG orbitals occupied unsymmetrically because EG orbitals directed towards the electrons directly, and they gained more energy compared with the T2G orbital. So as I told you, configurations with significant Jahn-Teller distortions where we get significant Jahn-Teller distortions where the EG electrons are asymmetrically occupied. So in all these cases, suppose D4 high spin. In D4 high spin, x square minus y square will occupy 1 electron, so EG will be unsymmetrically occupied. Similar for D7 low spin, again T2G unsymmetrically occupied. EG unsymmetrically occupied and T2G symmetrically occupied. Again for D9 configuration, EG unsymmetrically occupied, T2G symmetrically occupied. So in all these cases where EG are unsymmetrically occupied, we get significant Jahn-Teller distortion. Now look at the configuration where we get insignificant Jahn-Teller distortions. We get insignificant distortions where T2G electrons are unsymmetrically occupied. In all these cases, skip these cases, these are significant Jahn-Teller distortions. Now in D1 system, D2 system, D5 system, D6, in all these cases, T2G are unsymmetrically occupied. So these will make insignificant Jahn-Teller distortion. Now there are two kind of distortions. As I told you that Z bond along the Z axis can be elongated or can be contracted. Depending on this, we term these two distortion as Z out distortion and Z in distortion. So first I told you about Z out distortions. When the T2G electrons occupied Z square orbitals, then I told you earlier that Z axis, the orbitals along the Z axis will be more electron concentration, will have more electron concentrations, and the bond along the Z axis will be elongated. So the orbitals containing Z factor, that is the XY and YZ, are lowered in energy because Z axis are elongated. So these two orbitals containing the Z factor will gets lower energy. Now look at the picture. Z square getting lower energy, XZ, YZ getting lower energy. Now again there is a splitment among the EG orbitals, among the T2G orbitals. Z square gets lower energy. Similarly, x square minus y square will be in the higher energy level in order to maintain the average energy in equal state. So these are termed as Z out distortions. Now Z in distortions. This is the reverse case of Z out distortions. In this case, the bonds along the XY axis elongated or bonds along Z axis contracted or shortened. So orbitals with Z factor will be in higher energy level. That's why Z square gets higher energy level. Again, XZ, YZ gets the higher energy level. These distortions are termed as Z in distortions. So these are all about Jahn-Teller distortions. These are some pictorial presentation of Z in or Z out distortions. Their bond compressed along Z axis. That's why Z square gets higher energy level. Again here bonds along Z axis elongated. So orbitals containing Z factors will get more less energy. So these are a pictorial presentation of Jahn-Teller distortions. And thanks for watching.